Need a project plan that actually hits its target? By the end of this video, we'll explain how to write a project plan, how to use the top project plan tools to complete your project on time, how to customize our template to get you started, and if you watch until the very end, you'll learn how project planners completed production on the world's biggest masonry project since the Great Pyramids 2 years ahead of schedule. That's right, I'm talking about the Hoover Dam, a gargantuan megaproject that cost the equivalent of $860 million in today's dollars. It used 4.4 million cubic yards of concrete, a combined 140 million pounds of steel and pipe, and 6 companies all pooling their resources together to complete. This all required serious coordination, and serious coordination requires a project plan. More on that later. To write your own project plan, there are 5 key questions that need to be answered. To answer these critical questions, we've collected a series of top tools from our project plan template, like a PERT chart, critical path, work breakdown chart, project risk analysis, and issue tracker, which are just some of the many slides that are available in our project plan template. So now here's a breakdown of how to use these tools to write your next project plan. The first step to any project plan is the project scope. This is a detailed account of all the project's elements, like related activities, resources, timelines, and deliverables. However, even the tasks you do plan for can hold your project back. That's because many tasks are dependent on one another, even those that don't happen in sequential order. A PERT chart is a visualization that tracks these various tasks in a free-form flowchart to show their dependency to one another with arrows. Instead of a Gantt chart that flows from left to right in a timeline format, tasks might not be solely sequentially dependent, as you might have to go back and repeat work on one task that changes a future task, and vice versa. The arrows also dictate whether something is connected versus dependent without resources, where the tasks aren't connected to each other, but often still relate. For instance, think of how product launch is directly dependent on a feature test, but is indirectly related to a product website. You still need a website to sell your product, but you don't need a website to make your product, unless your product is a website. Know anyone like that?
Oh.
A great example of this is actually what happened when the 6 companies started the Hoover Dam project. They not only had to build a dam, but they had to build an entire town to house all the workers to build the dam. More on this at the end of the video. Next up, your project's timeline is vital to its success. In order to meet your timeline, you need to forge a critical path. Critical paths show the dependency and connection between a project's most important tasks. The template we created has multiple slides to help structure your critical path, either with a flowchart visualization or with a table visualization to map out the likeliness of the timelines, or with a table and Gantt chart to tabularize your critical path across the tasks, responsible team member, start and finish dates, duration, and current status of the task. The Gantt chart at the bottom of this slide divides these tasks into sprints, with subtasks underneath. Because this Gantt chart correlates to critical path, the arrows can be used to show the dependencies between these tasks. This can be used to determine which, if any, of the decisions can make or break one another. The next task in a project plan is to determine what resources are available. Work breakdown structure tackles resource allocation, time management, and budgeting all in one, so resources match up to the project scope you just created. This slide has a work breakdown visualized like an org chart and shows the main goal, tasks, and subtasks to accomplish the project. While this visualization has each budget listed under its task name, this can also be edited to track the role of the team member responsible as well. To track each task's progress towards completion, the middle of each task shows percentage-based status bars. For instance, if your task was to learn how to make a project plan, congratulations, you're 50% of the way done. So now, how do you manage risks associated with a project? This project risk analysis table breaks down the risks associated with your project and then ranks them based on their level of impact and probability of occurrence. Multiply these two together to calculate a risk value, which is an estimate of the total cost of the risk. Inform your analysis with this risk matrix to track risk likelihood against the level of consequence. For instance, if a risk has an extreme level of catastrophic impact and certainty, it needs to be managed carefully. Here's one last tool to help you with risk management: an issue tracker, which is helpful to assess if your project is on target according to what you thought at the start or if you need to push your timeline back. This issue tracker also pairs well with the PERT chart since dependent tasks can become issues. This is helpful for complex mid to large scale projects like, say, the Hoover Dam. So how did the Hoover Dam end up 2 years ahead of schedule? While the dam was the largest government project in history at the time, in order to win the bid, the 6 companies group had to put up the first $5 million themselves. Then, they faced fines for every day they went behind schedule. This incentive mandated that they find ways to stay on schedule. Great motivation for any project plan. One of the ways the project saved time was not waiting for the town to be built before they started work on the dam. If this was visualized on a PERT chart, the project planners could see that the 2 tasks were dependent without resources, as noted by the blue arrows in this visualization, since one required concrete and steel and the other required lumber and food. But in order to stay on track, they also had to get around another critical issue. The dam required so much concrete that if they poured it all into one block, it would take over 125 years to cool. This was the critical path needed to overcome to finish the project on time. They would have to break up this large task across multiple smaller tasks in order to reach their target end date. So what was their solution? Pour the concrete into 5-foot blocks at a time. Then use pipes to pump cold water through each block to cool it. This was to cool it enough to pour the next block on top of it. While 80% of projects don't set baseline schedules, this extreme attention to timeline made all the difference for the project planners at the Hoover Dam. If the tools to make a solid project plan is in your way, you need this presentation. Download the project plan template for more slides on the impact and effort matrix, project portfolio, status reports, stakeholder registers, task prioritization, and many more to save time and hours of work. Thanks for watching.